Hey everybody, Dr. Avizo here. In this video, we're going to talk a little bit about blood cells, and there's, a lot of information that we really are just going to try to consolidate down, into the really relevant, high-yield information that relates to each one of these blood cells. And a lot of this will be kind of basic information, and then we'll kind of build on this as we proceed through the series. So we're going to start this first video talking a little bit about the platelets. It's important to remember, where we're starting from, right? So we have these CD34 positive. Remember, these are CD34 positive. Right? And so from these cells, we can go down a couple different pathways. And we kind of touched on this, between the immunology series as well. This direction is going to get us down our lymphoid lineage, right? And then in this direction, the direction that we're going to be focusing on in this video, we're going to talk more about our myeloid cells. Okay, so we have the lymphoid lineage, which has a lot to do with the B cells, the T cells, the natural killer cells that we talked about in the last video. But then we also have our myeloid lineage. Okay, so we're primarily going to be going down this myeloid pathway, and that starts with this common myeloid progenitor cell, which gives rise to all the cells that we're talking about in this video. Okay, so we're going to start here with the megakaryocyte and eventually the thrombocyte. And thrombocyte is really just another name for platelets. You can see here, this whole process starts under a process known as thrombopoiesis. So thrombo referring to the platelet, and then remember poiesis referring to the synthesis of. And this megakaryocyte giving rise to a platelet, that's really the extent of what you have to know. These platelets are going to be produced and initially mature in the bone marrow. They'll then enter the bloodstream, and this is all going to be stimulated by thrombopoietin. Okay, and remember, if you're confused about what these hormones are doing, you can remember the suffix here, poietin, right? Again, referring to thrombopoiesis, the synthesis of what? Thrombo being platelets. Okay, so that would stimulate thrombopoiesis. Now, the thing that sometimes gets tested here about thrombopoietin is the location of where this gets synthesized. Now, remember, when we were talking about erythropoietin, we were talking about that being synthesized in the kidneys. But when we're talking about thrombopoietin, this is synthesized in the kidneys and the liver. Okay, and because the liver is kind of different from erythropoietin, classically, when you get questions on this, a lot of times they're asking about thrombopoietin synthesis being in the liver. Okay, so the liver plays a role with this. This is a very classic example of, if you knock out, your liver for whatever reason, right? If patients that have cirrhosis or have chronic liver disease, these patients will typically have thrombocytopenia or some platelet defect because of the impaired synthesis of thrombopoietin. So this is where that correlation between understanding, where some of these hormones are synthesized and then their effects kind of comes hand in hand. Okay, so that's something that I would remember. And essentially what this thrombopoietin is doing to stimulate thrombopoiesis is, again, like we just talked about, it's going to be stimulating the megakaryocytes in the bone marrow. Okay, so it's going to be stimulating the megakaryocytes in the bone marrow to proliferate, to mature, and then eventually get these thrombocytes or these platelets out into the bloodstream. And the thing about platelets is, in general, they have a very short half-life. It's usually like 8 to 10 days. A lot of these platelets actually will be stored in the spleen. Okay, so you'll have some of these platelets in the blood, okay, but then you'll have a pretty significant number of these platelets stored in the spleen. And so when you're looking at, a patient's platelet count, for example, you're looking at the platelets in the blood. You're not looking at, how many platelets they have stored in their spleen. Okay, so just to recap some of the primary functions here. So again, the big thing with the platelets is the platelet plug formation, and we're going to talk about this in great detail. We have a whole set of videos just dedicated to this, and this process is referred to as primary hemostasis, forming the platelet plug initially. Now, secondary hemostasis is referring to creating that fibrin mesh when we go through our coagulation cascade, and we'll talk about all of this, if you continue to watch the videos in this series. When you're talking about granules in these videos, especially when we go to granulocytes, there's a lot of different things that are in the granules that, you will try to remember. And, in terms of the importance here, I think that the big thing for the alpha granules is going to be von Willebrand factor as well as fibrinogen. Now, PF4 here is essentially standing for platelet factor 4. So platelet factor 4 is also going to be in the alpha granules, but in my opinion, it's not as high yield as these two, von Willebrand factor and fibrinogen. The other type of granules that we'll talk about are the dense granules, and we'll go into these in a little bit more detail when we talk about primary hemostasis. The big thing here you want to remember is that ADP is going to be in the dense granules, and then histamine and also calcium will be contained there as well. Again, in this situation, the big one that I would remember, if you can only remember one, would be the ADP. Now, the relevant pathology here, so thrombocytopenia, you're going to see this a lot. The cytopenia referring to a low number of what? Of thrombocytes, right? Of platelets. Thrombocytosis, just the opposite, right? This would be a high number of platelets in the blood. So in these situations, we're talking mostly about quantity, but then you can also have issues with the quality of your platelets, right? You can have qualitative platelet disorders. So in other words, you have issues, not necessarily with the number of platelets, but in the way that they function. And then we'll go through some very specific examples of these as we proceed. Now, the other thing you want to be familiar with is just being able to recognize platelets when you're looking, under a microscope, for example. And you can see here, so here's all of our red blood cells, right? So we have a lot of different red blood cells here, and then you can see these circles here. We've got another one here and here, right? So these circles are essentially going to be your thrombocytes or your platelets. And these are very common to see, if we were looking at these under a blood smear. And finally here you can see an example of a megakaryocyte. Now in general, it's highly unlikely that you're going to be tested, frequently on megakaryocytes. Just remember that megakaryocytes in a lot of situations, when you're looking at them, they're going to be in tissues such as the bone marrow, for example. When you're looking at platelets in general, when they show you a slide of platelets, it's typically going to be surrounded by these red blood cells. And again, the platelets are going to be those purple dots that you see. Okay, and so again, we'll see these again as we proceed through the video series, but it's good just to kind of have an introduction here.